Hello everyone and welcome to day 2. Last lesson we looked at arithmetic sequences, and so today we're going to look at geometric. And so if we think about it, arithmetic we added, geometric what do you think we're going to do? But multiply. And so the idea that adding, you can also subtract with multiplying. You can also multiply by a fraction, which in return if you multiply by 1 over something, it's the same thing as dividing. So just remember that arithmetic and geometric, you can always increase and or decrease. So this first example that we're going to look at is growth of bacteria cells in a petri dish. So we're going to start at 25 bacteria cells are placed in a petri dish. And the lab technician finds that the number of bacteria doubles every quarter hour. Notice that that's not every hour, but every quarter hour. Use words, graphs, so we can figure out what this is. Well, if it's doubling, okay, what function is it? Well, let's just actually complete the table below. So 0, we already know is 25. At 1 quarter hour, if we double that, that's 50. Double that, that's 100. Double that, 200, 400, 800, and all the way up. What is it when we multiply by 2? What function is that? If you guys don't know it, we need to know it. That's an exponential function. Okay? And what that looks like is we start out slow and we increase rapidly by the end. And in this case, we're multiplying. And so that's geometric, is when we multiply. Hopefully that helps you guys out. If we look at B of n, there are several ways to represent this, and again we've talked about it. The first one was the next now. What did we do? We multiplied by 2, comma, starting at 25. And then we know that it can be recursive. B of n equals B of n minus 1, the next equals now, multiplied by 2, comma, B sub 0, no time had elapsed, equals 25. Notice how they're the same thing, just written out. We talked about that with the arithmetic. And then we go into an actual formula. B of n equals, now not doing recursive, but an actual function. Okay, B of n equals starting 25, parentheses, we're multiplying by 2 to the n. That's exponential. So we have the next now, we have it written as a recursive that we still read it as next now, and then we have the actual function formula. I know it says to find it after 18 quarter hours, but can you imagine doing this? Again, just as a reminder, to find that you would have to start at B sub 0, and then go B1, B2, B3, B4, and keep going. That's just a pain. So we're not going to actually do B, but we're going to actually do C. We're going to find B of 18. The actual answer to that when you use a calculator is 6,553,600. And what does that represent? Again, the context is so key here. So after 18 quarter hours, there is 6,553,600 bacteria in the petri dish. Important to do that. Just as a reminder to you guys, I said it, but we can write it down. This is our starting value, and this is our rate of change. We're going to leave 8 and 9 for class, or 8 and 10. And we're going to go right into 13. 13 says, what is the common ratio? What is a common ratio? Common ratio is what we multiply by to get next term. So What are we going to multiply by? Go from 3 to 6, 6 to 12, 12 to 24. We're multiplying by 2. So our common ratio is 2. And it says, call the general term of the sequence a sub n. So a sub n. Suppose that the starting subscript for the sequence is 0, and then the initial term is 3. What is the recursive formula? So next equals, if you think about it, next equals now. What are we doing? We're multiplying by 2, and we're starting at 3. So when we write the recursive, a sub n equals a sub n minus 1, it's always the previous term, multiplied by 2, comma, it tells you a sub 0 equals 3. Now what happens if the subscript is 1? We still have a sub n equals a sub n minus 1 multiplied by 2. In this case, now we go a1 equals 3. Now let's go back and actually find our actual function formula. So the difference, just as a recap, this one is starting at 0. The beginning term is our 0th term. In this case, the beginning term is our first term. And we talked about this also with arithmetic. If this is our function formula, a of n equals our starting value, 3, multiplying by 2, to the n. Alright, if I want the first term, I'm going to take 3 times 2 to get the first term. But in this case, starting at the first term, we still get 3 times 2, but we have to go back 1. 3 to the n minus 1, starting at 3, so that when we plug in 1, 1 minus 1 is 0, we get our beginning term. So if we ever start at 1, we always have to have n minus 1 here. That's the key. Starting at 0 is just n, but starting at the first term, the equation now has an n minus 1 in there. So we have the same starting values, same rate of change. It's just where we technically begin is at n or n minus 1, or at 0 or 1, and then therefore the function is n or n minus 1. Let's think of it another way, and I know I will have talked about this last class too, but if I start at 0, I'm starting here. Okay, if I start at 1, the graph is actually shifted over here so that it looks like this. And that minus 1 actually shifts the graph to the right 1. And that's exactly what we did here. So it's shifting it over because our first term is 3 and not our 0th term. So just a thing there. Geometric recursive we just talked about, multiplied by r. Here's the equations depending on where you start at the 0th term or the first term. Everything that we should have already seen here. So in the final page of the notes for today, describe the difference between arithmetic, A, what are we doing? We're adding or subtracting, and geometric, we're multiplying. So what I would like you guys to do right now is, for A, B, and C, state whether it's arithmetic, geometric, or neither. If it's arithmetic or geometric, find the recursive formula and the function formula. And if it's neither, explain why, and if you could find a formula for it. So we're doing A, B, and C. You're going to state whether it's arithmetic or geometric, and then find the formula for it. Both recursive and function. We need practice with it. And so hopefully you found that A and B correctly, and you should have found that A and C correctly. You should have found that B was neither. And if you came up with a formula, I would love to hear it in class when you try to figure that out. It's a tricky one. So if you have questions on that, mark it down and ask me in class. But we had geometric multiplying by 3 and arithmetic adding by 4. Notice that the starting terms were both starting at the 0th term, and therefore we have no need for n minus 1. Moving on to the very last part of the notes, exercise number 6, generate the value of A4 given, here's the key word, guys, we're given that our first term is 2 and that we have next equals now multiplied by 3. Notice that we're starting at the 1, at the first term, not at the 0th term. And so therefore, we have to come up with an equation to find 4, because that's easier. So let's actually do that now. You could have done A1 to equal 2, A2 to equal 6, A3 to equal 6 times 3 to give you 18, and A4 to equal 18 times 3 should give you 54. But we don't want to do that to find A10s, just to paint. So let's write the formula out and then go back. So again, we have A of n equal, what is our starting value? 2. We're multiplying by 3. But again, since we start at the first term, if you notice, we only multiplied by 3 how many times? 3, but we got our 4th term, so we need to do n minus 1. So if we're looking for A of 10, 2 times 3 to the 10 minus 1. We started at the first term, we have to subtract 1. We get 2 times 3 to the 9th, and that should give us 39,366. Okay? And so writing the formula out is key. Knowing that it starts at the first term, we have to do n minus 1. We're going to finish up here figuring out when given 2 terms with one not being the initial term, whether the 0th term or the first term. We're going to figure out how to find that initial term and find the rate at which it's changing at, and then define the actual formula. So that's what we're going to do first. Let's actually start with the bottom one, the arithmetic one. We know an arithmetic is linear. And if it's linear, we know we have y equals a plus bx. A is our starting value and b is our rate of change. If it's linear, we need to find the rate of change to be the word, quote, slope, which is the change in y over the change in x. And if we look at these two terms given to us, we know that we have our 3rd term, which is 45, and our 9th term, which is 32,805. We can write them as points. Our input, we talked about this the first day of the lesson, our input and our output. So we're going to find change in y over change in x, which is 32,805 minus 45, which is 32,760 divided by 6, which is 5,460. The 5,460 is our rate of change. Now we have to come up with a formula. And remember that our formula is A of n equals A1 plus our difference times n minus 1. This is our difference right there. We need to find our first term. Well, how many, we started at A1, that's why we have n minus 1 here. How many did we move over? We have A3. How do we need to get to A1? We have to move over twice. Hence, we plug in, let me explain this one to you. We have our point 3, 45. We have our x and y. We know that this is our y, 45. We know that we're looking for A1. We know our difference, which is 5,460. And we know what n is. N is our 3. And if you do the math for this, if you solve, and for time purposes I'm just going to tell you, you get negative 10875. And therefore, we now have our difference, we now have our A1, we can now write our recursive definition for the sequence as A sub n equaling A sub n minus 1 next equals now plus 5,460 comma A1 equaling negative 10875. And if we needed to, we can write our function formula as negative 10875 plus 5460 times n